Welcome to the AI Research Roundup. I'm Alex. Today we're looking at this paper from OpenAI, introducing their new open-weight GPT-OSS models. The most striking result is that even after being intentionally modified for malicious use, these models did not reach high capability for dangerous cyber or biological tasks. And as well, their safety evaluation is incredibly thorough. This work also shows the models are still highly capable at reasoning and tool use. Alright, so let's dig into the models themselves. This table breaks down the two new models, GPT-OSS 120B and GPT-OSS 20B. What's really interesting here is their architecture. They use a mixture of expert system, which means that while the 120B model has a massive 117 billion total parameters, which are the internal settings the model learns, only about 5 billion are active at any one time. This design makes it incredibly efficient with the checkpoint size. Basically the saved model file, small enough to fit on a single high-end GPU. So given that efficient mixture of experts architecture, how do these new models actually perform? Well, these charts show their main reasoning capabilities. We're looking at a series of very tough benchmarks, like AIM, which is competition-level math, and GPQA Diamond, which uses PhD-level science questions. The key takeaway is that the GPT-OSS 120B model is extremely capable. On the AME 2024 math problems, for instance, it scores 96.6%, which is right up there with OpenAI's O4 Mini. And even the much smaller 20B model holds its own. Building on those impressive reasoning skills, these charts shift the focus to coding and tool use. On the left, we have Codeforces, a competitive coding benchmark where the score is ELO, a rating system where higher is better. You can see GPT-OSS 120B, especially with a tool, is right up there with O4 Mini. Then in the middle, we have SWE Bench for software engineering, and on the right, Tau Bench for function calling, which is the model's ability to use external tools. Across all three, the 120B model shows very strong competitive performance. Now, one of the really neat features here is how the model's reasoning can be adjusted. These charts show something called test time scaling on those tough math and science problems. The horizontal axis is the length of the model's reasoning, measured in tokens, which are like pieces of words. This is related to a technique called chain of thought, where the model explains its reasoning step by step. You can see that as the models are allowed to think longer, going from low to high reasoning effort, their accuracy smoothly increases. This is great for developers. So we've seen the models are powerful, but the core question is, are they safe? This is where the evaluation gets really serious. This table gives an overview of how they tested for biological and chemical risks. They're not just asking simple questions. They're testing things like wet lab capabilities, which is practical lab work, and something called tacit knowledge. Tacit knowledge is that subtle, hands-on expertise that experts have, but is really hard to write down. The goal is to see if the model can troubleshoot real-world lab errors. Moving from biological to cyber risks, this chart shows performance on a professional capture the flag benchmark. A capture the flag is essentially a cybersecurity competition, where the goal is to solve hacking challenges. The vertical axis shows the pass at 12 score, which is the percentage of tasks solved within 12 tries. The key finding here is that even when the GPT-OSS 120B model is fine-tuned to be its best at cyber tasks, reaching 25%, it still doesn't beat the older O3 model. This again supports the conclusion that these models don't significantly advance dangerous capabilities. So, to wrap things up, the big story here is the release of these very capable GPT-OSS models, which excel at reasoning and coding. But the crucial takeaway is the safety evaluation. Even with adversarial fine-tuning, which is an attempt to deliberately train the model for harmful tasks, they found it did not reach a high-risk level for biological or cyber threats. This whole process is part of their preparedness framework, a structured approach to assessing risk. It's a key step in releasing powerful